And our next speaker is Yuan, who got his PhD from the statistics department here. And then after that, he worked at Google for several years and is now a data scientist at Dropbox. So let's welcome Yuan.
Thanks for the introduction, Joe. It's really nice to be here. And thanks for being here for late Friday afternoon. So when I picked the title of this talk, I really had no idea what title should I use. Then my 5-year-old son was singing What the Fox Say. And my 3-year-old daughter was dancing the fox dance. And I said, oh, well, I just used this title, maybe a little cheesy. But then I thought about it. This actually describes what I do in my daily job. It's basically looking at the data and then try to answer questions from the data. And then most importantly, try to use the answer to guide decision making, which is crucial. And for those of you who may not know Dropbox, we are a cloud storage company. What we do is that we create a file system based in the cloud so that you can put all your files in, and then you can access it from anywhere and on any device. So it used to be that you would store all your files on a hard drive or a flash drive that you carry around. But then when it comes to using that file in other devices or in other places, it becomes a really awkward problem. So when Dropbox was created, it solves this problem very elegantly. Whenever you create a file or make changes to a file, the files are automatically synced to all your devices that are linked to the Dropbox account, including your desktop, laptop, your mobile phones, and your iPads and so on. So, since 2008, when our co-founder Ju wrote his first line of code for Dropbox on a Boston Chinatown bus, Dropbox has had a very fast growth.
Thank you.
So from 2008 to 2012, our users increased from 0 to 100 million. And especially recently, in the last year, we doubled to 200 million. And the number is growing fast. So these are some more numbers. We had hundreds of millions of users and hundreds of petabytes of data stored in our servers. And then our users sync billions of files every single day. However, one thing I want to talk about today is from one observation we had, that among all the files that are uploaded by our users, a large percentage of them are photos. And then we realized, okay, then photo must be a significant part of people's life, and what can we do with it? So let's step back a little bit and think about what we do with our photos. Years ago, before I had a digital camera, I would take a picture, and then if it is good, then I may scan it and store it somewhere, which most likely I can't find today. But then after some time, the digital cameras come out. I had a digital camera, so I took a lot of more pictures. I would plug it into my computer. I would create photos carefully, organize them carefully, and name the photos like weddings, graduation, Matthew's birth, Matthew's first birthday, Matthew's second birthday, and so on. And then this thing comes, a smartphone. Well, the grandfather of this phone come, which is iPhone, and then a lot of more smartphones came. So that you can take a phone and take a picture very easily. Now suddenly people are taking a lot more pictures at different times and locations, and then it becomes, people would get less and less likely to organize their photos because there are just so many. And also, when it's on your phone, it's just much harder to organize them. So when you think about the life of a photo, we have the creation. Basically, when you take your camera or phone, you click it, it creates a photo. And then if you have Dropbox, of course, you have the storage part covered. Then when it comes to viewing and sharing, since now you have so many photos, maybe thousands of them if you're like me, then how can you find the one that you really want to look from thousands of them? And also, if you want to say, I want to share the first birthday photo of my son with my parents, how am I gonna find them and then click each one of them and share them? So if we can make this process better, then the experience of our user would be a lot better. So that is the first problem I want to talk about today. I call it photo eventizing. Basically, if you face a large chunk of photos, like thousands of them, how can you automatically organize the photos into events so that each event would mean something to the user, and when the user want to share and want to view, it's easy for them to find it, and it'll be just one click away from sharing to whoever they want to share with. So when we try to do this photo eventizing, we think about, okay, what kind of features we have about the photos? We have time, when the photos were taken. We have location, if you enable GPS on your phone and some high-end cameras. And then also where you put the photos. Is the photo shared from somebody, or have you shared the photo with somebody else? And also a bunch of EXIF information about the photos, like which camera was used to take the photo, the exposure level, and so on. So all this information are in the photo file. So if we take all of this and then we use it to train a model to do photo eventizing, that would be wonderful. That's the question we want to solve. And then we think about it, okay, so we have a question we want to solve, and we have so many photos in Dropbox. However, what data can we use? Okay, because we want to do photo eventizing, but we don't actually have event to train our model. So basically, there was no, although we had so many photos, there was no data. So one obvious thing to do is that we hire people to look at some of our own Dropboxers donated pictures. So they looked at it and they say, okay, this group of photos should be one event. And then we hired a bunch of annotators, and then each one of them looked at a bunch of photos, and then they marked the photos, grouped them into events. So when we got the data, we are happy that finally we got some data, and then we can train our model to do some predictive modeling and then apply the model to all the other photos of our users. Then when we look at the annotated data, it becomes very interesting. One thing I think you would imagine is that people's opinion are very, very different. One thing this annotator think is an event, the other annotator would not. And the variation among the annotators are just so large that make the make the data really not very useful. And also when you present, because when the annotators annotate the photos, when they try to group them into events, they have to view the photos in some way. And basically, we designed the interface for them to view the photos. And later, we realized that, OK, this interface actually matters a lot, how they group photos together. As I just mentioned, there are multiple dimensions that a photos data has, like time, location, and other information. So there is no way that we can, well, there may be ways, but we can think of a good way of displaying the photos that would make it unbiased, so that the labeling of the events would not be guided by the way we presented them. And if we find a way, actually, then we probably already solved the eventizing problem. So this data is actually quite biased by the way we present it. So if we can't use this, well, we still use this data, but our confidence over this data would be not that high now at this point. So what do we do? So we said, OK, since we don't have very good real data, we just fake it. I think I just learned the term. Sorry, what the terms? If you fake the data set, it's called referred. Sorry, what was the term machine learning we use? OK, thanks.
I'm not sure that applies generally to faking, but.
OK, so what we do is that, since earlier, as I mentioned, when we had the time to organize our photos, we put them. Some of us may put photos into like well-organized folders and name them with specific events names. So we do have, if many people put all their photos in their Dropbox. So we do have lots of well-organized photos in our Dropbox account, like me, the old data, and also many other Dropboxes. So again, we used some donated data set by Dropboxers and their family and friends. And then we try to search in their Dropbox account for a good hierarchy of photo structures that may represent events. And we think this may make more sense because those are organized by the creator themselves, and those may mimic the actual events more reasonably. So, and also a good thing is that this is not limited to like the number of annotators we can hire, so we can do this in a larger scale. However, it is still noisy because none of us really organize all the photos very well. We have directories that are well organized. At the same time, we also have other directories. Say the directory's name is others, the ones that you don't know where to organize, so you just throw them into one folder. And there are also directories called camera uploads. There are also directories called download. These are all bad directories in some sense that we don't want to use because those does not represent an actual event. So we have to do lots of cleaning on this self-organized photo structure. In fact, we actually wrote an optimization algorithm using dynamic programming, trying to remove the unusable directories. But we want to keep as many as possible while eliminating the overlapping of time and location and so on, so that we have a well-organized, self-contained sets of events. And then we will just learn from those. And that's another story where I probably won't talk too much about today because there are lots of modeling skills you can use, like tree and other regression things. And then, so basically during this process, the hardest part is not the modeling part. The modeling only takes a few days or maybe 2 weeks, just because there are other evaluation we have to do. but cleaning the data and getting the data set that we can learn from, as well as getting a test set we can evaluate the model on is the hardest part of this project. And these are a few examples that we were facing so that you may get a sense of what the data look like in the time and location scale. So the bottom x-axis and the y-axis, these are locations, positions in the world. And then the upper x-axis is time. So that you see two discrete sets of points with numbers denoting how many points are overlapping. So one is 10, the other one is 12. And these two happen at a different location, and then they happen at different time. So this is an easy example, and they should be two events. This is another interesting example that there are also two clusters of photos. And then they are very, very far apart. So these are in the units of miles. Basically, it's 8,000 miles apart, so it's the other side of the world. But the photos are taken at the same time. So this is also easy because there's no way this person can fly between these two locations that quickly and take photos all the time. So these are two separate events as well. This is another example of, actually this is my own data. We took a road trip from one place to another, and then during the road trip, we took a bunch of pictures. So you see this dotted line is basically the trail of the trip. And then also you see all these small groups of photos, they happen in a time sequence. So this one is a little tricky. This is where the inconsistency or variation among annotators would come. So some people may think this is one road trip, so we should group them into one event. And some of them, some users may think, because each dot is actually pretty far apart if you look close enough. So they should be different events. And from our point of view, because the purpose is to make it as easy as possible to view and to share. So if a user wants to share a group of pictures that were taken at one view, one vista point, then selecting those photos from a big bunch may not be easy enough. So we prefer to have smaller events than a big event, but also it depends on how many photos there are and also how far they are apart. So basically, it'll be in the end, the algorithm is a tree-like decision. It's a decision tree that would decide based on time, location, directory, and sharing properties and so on. Try to decide, okay, whether this two sets of photos should be in one event or not. And what we can do to make this even better is that we can have a personalized parameter, so that when users view their photo events in an interface, they can make adjustments. So they can merge two events, or they can select a few to separate them from the main event. When we observe things like that, then we learn that, okay, this user wants to have things this way instead of the other, so that we can have that personal parameter to make the eventizing result different for each user. So here is another example another observation that we have, which may be interesting when our mobile device is used compared to non-mobile devices, for example, a camera. So So one observation we had is that, which is we didn't expect, is that cell phones actually used to take photos at night more than other cameras. So the x-axis here is basically time of the day, and you see from 18 hour to 24. Cell phones, mobile phones are used more often than other kinds of cameras. So if you're a developer, then this may tell you that developing a night feature for your phone, for a mobile phone, may be something interesting to do. Cool. So this summarized the photo application that we had that we handled in our data science team. And then another example we have is about revenue. Dropbox has had steady revenue increase along the years. But we always want to increase the revenue. Who doesn't, right? So one thing we can do is to prioritize the sales leads so that our sales team can have their time better spent to bring in more revenue. And this is not a Dropbox problem. This is a problem for almost any company. And one company did it really well, which is LinkedIn. So a few years ago, LinkedIn started working on a problem like this. But they were in a very unique position because their data is so valuable. Their main revenue source is from basically pro subscription for recruiters. And they know the targeting so well because they know in each company who are the recruiters and how many people there are and whether they are hiring and so on. So they built up this machinery to basically rank all the companies, how likely they're going to subscribe to the pro usage of their accounts. And then they know exactly who to contact. And even better, they calculated probability of how likely the lead would convert depending on who is going to call them, who is going to contact them, given the history of all the sales reps. So with all this, they even added like performance review. So because sales are reviewed by the sales they made, and how to reward them is actually very important to keep them very active and successful. So they have all this system running in an automated way that use the LinkedIn data. So we want to do something similar, although we don't have the same set of data, but we do have something that is nice, because if you're a company, say Harvard.edu, which is not a company, but we know that how many Harvard.edu emails have registered a Dropbox account. And we can have a summary view of, in this domain, what the kind of activities are, how many users are active, and are you using it for work or for photos, and so on. This also put us in a very good position that we can try to score the sales leads, and so that our sales reps can focus on the most important leads with the highest probability to convert. And also we can make suggestions to what kind of action they should do. Should we call them? Should we email them? Because different kinds of leads may respond differently to different actions. So while we're solving this problem, one tool that I use very often that I want to introduce is called Ruthit, which is a algorithm developed by Professor Jeremy Friedman in Stanford. I worked with him a lot when I was at Google, and it turns out Ruthit is a tool that is very versatile and very robust. So this is one kind of plot that Ruthit would generate. It's a relative importance plot for all the predictors I have for this lead scoring project. And it tells me, okay, the most important predictors are like lead source, how many licenses they want to purchase, they're interested in purchase, and where they are, if it's a phone chat, how long they have chatted, and so on. And then, even better, there is a partial dependence plot for each of the predictors. So, for example, the first one is the lead source. For each different lead source, whether they come from web, from a phone, from chat, how important that is, and also how many licenses they want to buy. So if you look at the top second plot, you see that if you want to buy if you want to buy more than 0, there's a jump, because somebody may feel 0 because when they're not very interested in. But when the number is super high, it also means that that person may just fill in random numbers, or it's an organization too big that is very hard to convert. So, and there are also examples like chat transcript. If this lead had a phone call with our sales rep and they chatted for an hour, which the transcript would be very long, then it's more likely that this person is sincerely interested. So it has a higher chance to convert. So these are example plots generated by Ruthit that I think is very convenient. So besides scoring the leads and ranking them, I think a more important role for the data science team to solve is to provide an end-to-end solution. So having a model, having a score is just not enough. We have to make it simple enough for the sales team to use, and for them to contact the leads. For example, we can generate a document like a PowerPoint automatically, and then so that the sales have something solid, concrete to present to the customers. Or how about we tell them, we also select which sales rep should work on this lead, because there is a higher chance for this person to succeed. Or we would like, another important point that we want to solve is that how should we evaluate this? This is actually very essential almost for every project that we work on. Whenever we make a prediction, make a predictive model, in the end we want to tell the CEO, okay, the model we created when we applied it actually has a 10 million revenue impact on our company. And we want to have this number even before this project is started to work. Because without a number, it's hard for us to get resource to understand why this is important. Because we would have to have resources like engineers to work on things and so on. So how do we evaluate the performance of the lead scores? Then we have to run certain experiments, and also have a lot of conversation with the sales team to have them agree on running this kind of experiment, which actually very often is very hard to do. So with that, I guess I'm pretty out of time. And so these are the two examples, the photos and the sales lead scoring are two examples of what we do, what the data science team do at Dropbox. I'd like to thank you, and any questions, I'll be welcome.
So there's time just for one question, and maybe you want to go to that center.
Yeah. So you talked a lot about creating events out of the photos. I was just wondering, what percentage of photos do you have no information for whatsoever in terms of time, location, all the EXIF information has been stripped away? And then secondly, I was wondering if Dropbox has any plans to use advanced image object identification in images to classify photos in any ways that would be useful for users?
Yeah, very good question. So there are quite a lot of photos that don't have any information. However, those may not be photos that we want to show. For example, some downloaded images and so on. Those may not be photos that are taken by the user. So grouping those into one single event may not hurt. I don't have the exact percentage at the top of my head, but there are quite a lot of them. For the second question, I think sorry, what was the second question?
Do you guys have any plans to, implement some kind of image object identification algorithms to group photos? Like you're talking about like grouping photos as graduation events or whatever. I mean, it seemed reasonable that you could probably do this some way on object identification, or that's just one example, but.
Yes, we do. We do have plans of doing that. And if you're working on computer vision, then we're very interested to, we have people working on computer vision, and I think we're hiring more computer vision people to work on those projects. But I don't have a detailed roadmap what kind of features we're developing.
Yeah. Okay, thanks, Yuan. Yeah, it's almost impossible.